The properties of the refractories and the refractory materials are important and fundamental to the development, improvement, quality control, and selection of refractory linings. Where the wrong choice leads to refractory failure. In this course, some important points will be explained. Defining the causes of refractory failure. Course 2. Alkali attack. Refractory matrix. Al2, O3, SiO2. Alkalis. K2O, Na2O. Reactants. SO3, Cl. Reaction products. Potassium sulfate. K2, SO4. And potassium chloride. KCl. New phase formation. K2O. Al2O3. 6SiO2. Na2O. Al2O3. 6SiO2. K2O. Al2O3. 6SiO2. Na2. Al2O3. 2SiO2. Chemical attack. 1. Penetration of the pores. 2. Reaction with the refractory matrix. 3. Formation of new phases. 4. Volume increase up to 36%. 5. Formation of cracks. 6. As spalling kill inlet chute, spalling with preheater, hot spot at hot gas duct, hot spot at kill hood, hot spot at grate cooler roof. What kind of lining damage? Numerous where stress of a chemical, thermal, and mechanical nature are overlapping in kill operation, due to an interchange of kill feed and flame. The following typical lining damage in rotary kill can be differentiated. A. Chemical wear. 1. Melting pits due to eutectic reaction. 2. Alkali salt infiltration. 3. Redox influence. B continues. B. Thermal wear. There are several reasons for this. 1. Overheating. 2. Mild infiltration by overheating of the kill feed. 3. Spalling due to thermal shock. 4. Recrystallization. C. Mechanical wear. There are several reasons for this. 1. Displacement. 2. Curved spalling due to excessive pressure. 3. Destruction due to ovulation forces. 4. Formation of grooves. 5. Shear stress and retention rings. Problems related to lining displacement in kill. The most important forms existed. 1. Lining is twisted and bricks line will take a spiral shape. 2. Bricks not touched the kill shell at top part of kill. 3. Bricks twisted in position to each other. 4. Bricks tend to move in direction of kill shell. In all this condition the bricks will have 1. Broken edge either on radial or axial direction of kill. 2. Cracks and fracture. 3. Top part of bricks are missing. These phenomenon due to 1. Ovality is very high. 2. When kin is cooled very quickly. What is remedy? There are a number of notes that must be taken. 1. Bricks should be installed as tight as possible. 2. Bricks size mixing should be correct, to be sure the bottom part staying on the shell. 3. Proper heating up and cooling down. 4. Reduce the reason for ovality as possible. 5. Proper adjusting the burner. 6. Keep the kill without unnecessary stoppage as possible. Lining drift. We can see in this picture widened radial and vertical joints, lining drift. Lining twisted. We can see in this picture lining twisting at an early stage. We can see in this picture lining twisting at an advanced stage. Lining twisting and shearing cracks. We can see in this picture lining twisting and shearing cracks, or shearing fractures bricks. Lining twisting and shearing cracks. We can see also in this picture lining twisting and shearing cracks, or shearing fractures bricks. Bricks adjacent to nose ring damage. Phenomenon. Mechanical destruction of bricks. Cause. 1. Increased thrust within the bricks. 2. Bricks may jump on the retaining ring, and in end will just fall down. Remedy. 1. Installation of bricks in this area should be correctly. 2. New design of retaining ring, Mijatu and Vecher design. Lining damage of retaining ring area. We can see in this picture the old type retainer ring is unable to arrest the thrust. Lining damage in the area of retaining ring. See also this video. We note bricks in contact with the retaining ring are sheared off by excessive lining thrust. We can see in this picture the new design of retainer ring. Depending on the manufacturer, there are different designs. Kill bricks fall down. A. Sometime during heating up, or after start up, or after short time of operation. Some rings may 2 or 3 rings fallen down. Cause. Here are some of the main reasons. 1. Improper installation. 2. Bricks sizes ratio unknown, and random fixing. 3. Quick rotation, while the kill still cold. 4. Excessively high ovality, in second tire. When shims under tire, are excessively worn out. Brick spalling. Spalling, can be defined. Leads to losing the top part of brick, hot face either partially or the whole upper part is lost. Spalling can take up to 70%. The main causes of spalling can be caused by many factors that lead to lose the top of brick. A. Thermomechanical stress as result of 1. Rapid decrease in temperature during cooling down. 2. Very hot at burning zone, accompanied by very cooling down. B. Mechanical stress caused by 1. Deformation of kill shell, due to high ovality. 2. Loosing of brick lining. C. Structural change, caused by salt infiltration of bricks, and structural changes. Brick spalling. We can see in this picture convex hot faces in direction of kill center line. Brick spalling. We can see in this picture hot face spalling irregularly distributed, of circumferentially. Thermal shock. We can see in this picture split-like spallings in 2 to 3 centimeters layers. Thermal shock. It is caused by several factors. 1. Quick heating up. 2. Sudden cooling down. 3. Coating losses. Ovality. Ovality can be defined as is the measurement of shell deformation during the course of kill rotation. Shell ovality measurement is the only accurate predictor of refractory life. We can see in this picture damage of refractory bricks due to ovality. About 3 months of kill operation. Among the most important phenomena is ovality. 1. Deep outbreaks of single bricks. 2. Increased clearance on tire shoes, increasing ovality. Grooves. One of the most important phenomena that occurs. We can see in this picture. 1. Parallel grooves 2 or 4 bricks wide of deep spalling appearing along the axis. 2. Excessively tight key line. Thermal expansion. The main reasons for this is 1. No installation of cardboard spacers. 2. Convex spallings in longitudinal. 3. Direction of bricks. 4. Insufficient clearance in the expansion joints. 5. Frequent stoppages of operation. Displacement. The main reasons for this is 1. Cold face wear from rubbing against the kill shell. 2. Displacement of the lining. 3. Loose installation. 4. Increased kill ovality. 5. Deformations of the kill shell. Liquid infiltration. The main reasons for this is 1. Lava-like coating solidly connected to the bricks, and bricks with surface. 2. Overheating of clinker, with formation. 3. Increased liquid phase, infiltrating the hot face. Corrosion of chrome ore. The main reasons for this is 1. Yellow-green discoloration, and brittle surface with cracks. 2. Corrosion of chrome ore by reaction with alkalis, resulting in the loosening of the brick structure. Hydration. The main reasons for this is 1. Spider web cracks from the surface into the bricks, and possible disintegration. 2. MgO and CaO react with water, resulting in a large volume increase. What could possibly go wrong? Watch this video to see what I mean. In the rotary kiln, there are several actions that go wrong, particularly with refractory bricks. This may lead to disasters, both minor and major, as a result of these errors. The inside of a rotary kiln. As you can see in the picture, the hotspot occurs as a result of the fall of the refractory bricks and the lack of a coat on the refractory bricks. The first reason: storage. One of the most important factors affecting the viability of refractory bricks is storage. Please follow the instructions below. 1. Check materials upon arrival for transport damages. 2. Store refractory materials under roof in ventilated, dry rooms and protected against rain, splashing water, snow, from all sides. 3. Under tropical conditions, open plastic shrink wrapping to avoid condensation of water within the pallet. Maximum shelf height. Magnesia and alumina bricks. 4 pallets. Lightweight and insulating bricks. 2 pallets. castables, gunning mixes, and mortars. 2 pallets. The second reason. Installation. The most common mistake that leads to refractory brick collapse is the first. One of the most important aspects of a correct installation is the use of skilled and experienced labor. The second point. In the right places, the right type of refractory brick. The third point. Shelf life of basic bricks, aluminous bricks, and mortar. The third reason. Corrosion. We can see in this picture corrosion holes, arrow, within a basic brick grade exposed to strong thermochemical overload. There are different types of wear. 1. Corrosive wear. Due to chemical reactions between the charge reagents and the refractory materials during kill operation. 2. Abrasive wear. Due to the large size of the charge being processed. Fourth reason. Excessive coating in burning zone. We can see in this picture construction of the inside free cross section due to coating ring formation. Brief about burning zone coating. Coatings and rings. The coating is the buildup of clinker and dust on the inside of the kiln, generally confined to the burning zone. The coating is necessary to protect the burning zone brick and kiln shell from the high temperatures and abrasion that occur in the burning zone. Coating is formed during the start-up operation and consists of particles of clinker and dust that combine with the soft surface of the heated bricks. Continuous improvement. 1. Proper refractory selection. Consistent, good installation practices. 2. Refractory-friendly operating practices. Good mechanical condition of equipment. Establish the causes of lining wear and damage. 3. Monitor and optimize current situation. Be aware of developments. This is a very important course, and I hope it will benefit you. If you have any questions, thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.